Hello dear students, in the previous class we learned about the equations of motions that are v equal to u plus at, s equal to ut plus half at square and v square minus c square equal to 2as. In this class we will solve some of the questions related to those equations of motion. Okay, so here the first question is, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Okay, a train starting from rest. Initially, the train is at rest position. Attains a velocity of 72 km per hour. This is the final velocity in 5 minutes. This is the time. Initial velocity rest, that is 0. Final velocity 72 km per hour. Time is 5 minutes. Assuming that the acceleration is uniform. Okay. Find first point the acceleration. Here we need to find the acceleration. Second point, the distance traveled by the train for attaining this velocity. That means if the train will move from the rest position, that is 0, to the final velocity 72 km per hour, what is the minimum distance that the train has to travel within 5 minutes. So let us solve this question. Here the initial velocity of the train u is equal to 0. Final velocity v is equal to 72 kilometer per hour. Okay. Now if you convert 72 kilometer per hour into meter per second, it will be 20 meter per second. 20 meter per second. 72 km per hour is 20 meter per second. How to convert this one I have already told you in the previous classes. Okay. Now time taken is 5 minutes. 5 minute, as you know that 1 minute is 60 seconds, so 5 minutes will be equal to 300 seconds. Okay, 5 minutes is 300 seconds. Now acceleration, you know that v is equal to u plus a t. From here, if you are going to find out acceleration will be equal to v minus u divided by t. If you put the respective values, here v is equal to 20, u 0, 20 minus 0 divided by time is 300 second. 300. So 20 minus 0 is 20 divided by 300. So it will be 20 divided by 300. Now this 0 will get cancelled with each other. 2 divided by 30 is equal to 1 divided by 15. 1 divided by 15 meter per second square. This is the acceleration of the train. Okay. Now here the first part of the question is over. Now we'll come to the second. Here in the second part, the distance traveled by the train for acting this velocity. You need to find out this distance. Okay. So you know that s is equal to 1 ut plus 1 by 2 at square. This is one formula to find out the distance traveled by the body. We have another formula, that is v square minus u square is equal to 2as. Out of these two, you can use any one, either this one or this one. Okay, so let me use the second formula. So if v square minus u square is equal to 2as, then s will be equal to v square minus u square divided by 2a. So what is v here? V is 20 meter per second. 20 square is 400. 400. U is 0. So 0 square is 0. 400 minus 0 is 400 divided by 2a. 2 into 1 divided by 50. Acceleration is 1 by 50. So 2 into 1 by 50. It will become 400 into 15 divided by 2. Now these 2 and 400 will get cancelled out each other. It will be equal to 200 into 15. 200 into 15. 200 into 15 is equal to 3000. 15 2s are 30, double 0. Now 3000 meter, or which is equal to 3 kilometer. Okay, so this is the answer of the question. So your acceleration is 1 by 15 meter per second square, and the distance traveled by the train is 3 kilometer. Okay. Now let us come to the second question. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Here, the initial velocity is 18 km per hour. Final velocity is 36 km per hour. To get the velocity from 18 km per hour to 36 km per hour, 5 seconds time is required. Okay. Calculate the acceleration, then the distance covered by the car in that time. So these two questions are same. The only difference is in question number 1, the initial velocity of the train was 0. Here the initial velocity is 18 km per hour. Final velocity is 36 km per hour. So all you do is to convert this kilometer per hour into meter per second, the initial and final velocity. Then the process will be same to find out the solutions of these questions. So I hope you can solve this second question on your own. Okay. Now this is the third question. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brake, calculate the distance travels during this time. So here, suppose this is a car. Okay. The car was moving with an acceleration of 6 meter per second square. So according to this question, the brakes applied to a car produce an acceleration of 6 meter per second square. The car was moving in this direction. Okay. So when the brake is applied, after certain time what will happen? The car will come to rest position. Okay, here it is given if the car takes 2 seconds to stop. Initially the car was moving. After 2 seconds the car will stop. So here initial velocity is u, which is not given. Okay. Final velocity is v, which is equal to 0 because it will stop when the brake is applied. So when the brake is applied, the acceleration produced is 6 meter per second square. Okay. So here from this position to this position, the time taken by the car is 2 seconds. It is given here 2 seconds. Okay, so let me make you understand this question again here. So here this is a car. Initially the car was moving with certain velocity u, that is the initial velocity. When the brake is applied, after 2 seconds the car will stop. Okay. Car was moving, when brake is applied, after 2 seconds car will stop. So initial velocity is u, which is not given in the question. Final velocity is v. Okay. Final velocity is v, which is equal to 0 because it is stopped here. From this position to this position, the time taken by the car is 2 seconds. So when the brake is applied, the acceleration produced is 6 meter per second square. Okay. So here you need to find out, calculate the distance traveled during this time. What is the distance traveled from here to here? What is the distance traveled by the car? Okay. So to find out distance, we have two formula. What are those formula? First one is S is equal to ut plus 1 by 2 at square. Second one is v square minus u square is equal to 2as. Now in these two formula you can see the initial velocity is required to find out the distance traveled by the body. Here this is the initial velocity u. Here also this is the initial velocity. To solve this question, first we need to find out the initial velocity here. Okay. So now we have another formula that v is equal to u plus at. Okay. Here what is v? V is 0 as per the question. V is 0. U we don't know. We need to find out this one. Plus a. Here acceleration will be minus 6. Why it is minus 6? Now see what is acceleration. When the velocity increases with respect to time, it is called acceleration. But here when brake is applied, the velocity is decreasing. Okay. So as acceleration being a vector quantity, the increase in speed means positive acceleration. Decrease in speed or decrease in velocity with respect to time means negative acceleration. In positive acceleration, speed is or velocity is increasing. Okay, so when velocity decreases, it will be negative acceleration. So here it will be minus 6 into time taken, that is 2. If you solve this one, your initial velocity will be equal to 12 meter per second. Okay, 12 meter per second. Now here you need to find out this distance traveled by the body. So here you can use any of this formula to calculate this one. You can use this formula, first one, or you can use this one. Just put, suppose you are using this formula, this second one. So what you will do, in place of v you put 0, in place of u you put 12, then 2, this is a constant. A, it is given 6, again it will be minus 6 because acceleration here we are taking negative. Then you solve it, you are going to find out the value of the distance traveled by the car, okay, or displacement traveled by the car. Okay, try to solve this question on your own. I have already discussed how to solve this question. Okay, so in the next class we will talk some of the more examples. Thank you and have a nice day.